GFL3000 kit contains a receiving frame, a receiving box, a set of black and red connecting leads, a dual powered transmitter with rechargeable battery, a battery charger, a ground stake, and an operating manual. The transmitter uses a 12-volt rechargeable battery. The battery comes disconnected in shipping. To connect the battery, remove the screws located on each side of the transmitter control panel. Carefully remove the rubberized terminal covers and connect the spade clipped wires to the battery. Then replace the cover and tighten the screws. To recharge the transmitter battery, connect the charger to the charging receptacle on the transmitter. Then plug it into a wall outlet. A cigarette lighter recharger is also included. The battery level indicator on the transmitter's face will indicate the amount of charge on the battery. The receiving box requires one 9-volt battery. To install the receiving box battery, remove the screws on each side of the receiver and remove the cover. Tightly connect the 9-volt battery to the battery boot. Then replace the cover and screws. Assemble the A-frame receiver by placing the receiving box on top of the receiving frame and secure it with the 2 thumb screws attached to the A-frame. Connect the red and black leads attached to the A-frame to the respective outlets on the receiving box. The GFL3000 is designed to pinpoint the exact location of a ground fault in a cable. The GFL3000 is not intended to locate the entire path of a cable. To effectively pinpoint the location of a fault using the GFL3000, the path of the cable must be previously determined and the wire must be in direct contact with the earth. To demonstrate that the path of the wire has been previously determined, the wire has been placed above ground. The fault is illustrated with a flag for further clarity. In cases where the wire is contained in conduit, the conduit will interfere with the locator signal and not result in an accurate reading. Isolate the cable to be tested by disconnecting it at both ends. Make sure the cable is disconnected from power, components, or anything else that could transmit an electrical current. This forces the current generated by the transmitter to exit the cable at the fault. At either end of the cable, and with the transmitter off, connect the black lead to the ground stake and push the stake into the ground as deeply as possible. Connect the red lead to the cable that is being tested. Note that if the clock is indoors, the black lead must be connected to its own ground stake where the wires exit the building. Do not use existing grounds in the building. Before turning on the transmitter, be sure no one is touching the stake, cable, or leads. When turned on, the transmitter will produce a beeping sound indicating current is being transmitted. Select low or high power as per your preference. High power will find all leaks, large or small. Low power will concentrate on larger faults. Remove the black insulating covers on the probes of the receiver. Turn the receiver on and place the receiver probes into the ground along the path of the cable. As the transmitter pulses the current, you should see the needle on the receiver kick in the direction of the fault. Watch for the direction of the initial kick of the needle and disregard the rebound kick. Remove the A-frame probes from the ground and move it in the direction of the initial needle kick along the path of the cable. Reinsert the probes into the ground and observe the direction of the initial needle kick. Continue down the path of the cable in this manner until the needle kicks in the opposite direction. This indicates a fault is between the last 2 places the receiver probes were inserted. Continue to zero in on the fault by following the initial needle kicks. When you are directly over the fault, the needle will cease to kick. Mark this spot for repair. Before repair, turn off the transmitter and disconnect it from the cable. Never touch the transmitter, leads, or the cable being tested while the transmitter is on, and do not use the transmitter in the rain. Failure to follow these precautions could lead to injury or death. Cables that contain many faults can be confusing, as all the faults exhibit some needle kick. To minimize confusion, start near the transmitter and work your way along the cable, fixing the faults as you locate them. If you are next to the transmitter when using the receiver, the needle can kick in the direction of the transmitter. Move further down the cable, away from the transmitter, to get the proper direction of kick. It is not uncommon for needle kicks to cease between the transmitter and the fault. As you move away from the transmitter, the needle response should decrease and could eventually stop. The needle will begin to kick again as it nears the fault. Small faults may be indicated by weaker kicks. To focus on larger faults, turn the transmitter power to the low setting. If you are unable to insert the probes into the ground due to concrete or asphalt, wet sponges between the ground and each probe can increase the conductivity of the frame. To bridge large obstacles, you can extend the frame by wrapping one end of wire around 1 foot of the A-frame and the other end around the screwdriver. Then use the screwdriver as you would the second probe,